for two extension slopes of parallel and perpendicular lines. First thing I'd like you to do before we start is go ahead and do your warm-up. Hit pause and then start the video back up once you have completed your work. All right, nice job. You should notice that the first two slopes are the same. And then if you take a look at the second one, the slopes are opposite reciprocals. So that's just a hint as to what is to come. Now, if I look at these two lines are parallel. That means if I extend them in the plane, they will never cross. Now, if you look at these, what do you notice about the slopes? The slopes are exactly the same. So if I have two lines that are parallel, that these are, the slopes will be the same. So lines in the same plane that do not intersect are parallel lines. That means if I extend them forever and ever, they'll never cross. Now these non-vertical, that means lines that look like this, those are vertical. Non-vertical parallel lines, vertical going this way, those slopes are undefined. So non-vertical parallel lines have the same slope. Now, if I do look at vertical lines that go like this, we do consider them parallel. So all vertical lines, even though the slope is undefined, they are still considered parallel. So let's take a look. Now, these lines to me all look parallel. Now, none of them cross within this window, but if they extend, we may not have parallel lines. It's just right now I'm not sure. So the only way I can check is by finding the slope of the line. So let's call this A, B, and C. So if I look at the slope of A, I'm going to go up 4 over 1. If I look at the slope of B, I'm going to go up 5 over 1. And if I look at the slope of C, I'm going to go up 1, 2, 3, 4 over 1. So that means A and C are parallel because they have the same slope. Now, let's take a look at these two lines right here. These are what let's take a look at these two lines right here. These lines are perpendicular. Now, I know they're perpendicular because perpendicular lines are marked by a right angle. That means two lines intersect, forming a right angle. Now, notice the slope. This slope is -2, and this slope is 1/2. 2 and 1/2 are reciprocals, but this one's negative and this one's positive. So this is what we call opposite reciprocals. So if I have a slope, that's the opposite, so instead of negative it's positive, and a slope that is a reciprocal, I have two perpendicular lines. So lines in the same plane, so they're on the same graph, that intersect at right angles, that means 90 degrees, they are perpendicular. Two non-vertical lines are perpendicular when the product of their slopes is -1. Now you might be thinking, what in the world does that mean? Well, if I were to multiply these two slopes, -2 and 1/2, I'd get -1. All of this is just fancy for saying non-vertical lines are perpendicular when their slopes are opposite reciprocals. So vertical lines are perpendicular. These are vertical lines to horizontal lines. So if I have a vertical line and a horizontal line, I will always have two perpendicular lines. So let's take a look. Now I'll be honest, both of these to me look perpendicular to this one, but we need to find the slopes. So let's do line A, B, and C. So the slope of A, I'm going to go down to, my slope is negative, over 6. So my slope is -1/3. My slope of B is also negative. So I'm going to go down to 1, 2, over 1, 2, 3, 4, 5, 6, 7. Now, I know these two are not parallel because we do not have the same slope. So let's take a look at the slope of C. I need an opposite reciprocal here. So I'm going to start here. I'm going to go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2. So the opposite reciprocal of this one is 3. The opposite reciprocal of this is +7/2, which means B and C are perpendicular. B and C are perpendicular. Nice job.